All right, so when I'm looking at the first one, they're asking about different things. They're asking about the vertical asymptote, which means I set the denominator equal to 0. So I know the VA is x equals 1. And the VA here is also x equals 1. Okay, so they actually have the same vertical asymptote, so B. They have the same horizontal asymptote. Okay, to get the horizontal asymptote for this one, there's an imaginary plus something over here. So that means the AJ is y equals 0. And when I look over here, we compare the degrees. The difference between this one and this one is this one has an x in the denominator. In the numerator. So that means I'm going to be comparing them. They have the same degree. So I go 1 divided by 2 is 1/2. This is the kind of work I want to see. You can't just circle things. This is going to be worth a bit of points. So they do not have the same horizontal asymptote, so A is out. They have the same end behavior. I don't care about that. But the same y-intercept, that's a little bit different. That's stepping it up. So when we're dealing with the y-intercept, we're dealing with 0, something. So what I'm going to need you to do is I'm going to need you to plug in 0 here and 0 there. Yes, it's a little bit new, but you have 2 days to review. So you're going to go 7 over 0 minus 1. 7 over negative 1 is negative 7. So the y-intercept here is 0, negative 7. That's my y-intercept there. And then my y-intercept here, plug in 0. 0 minus 7. 2 times 0 minus 2. Negative 7 over negative 2 is 7/2. So my y-intercept is 0, 7/2. Okay? And for the same end behavior, here's the thing. This one looks like this. Top right, bottom left. But this one is going to be more complex. This is when you have a VA equaling x1, 1/2. Okay? So the problem is you actually don't know if it's going to be top right, bottom left, which would make it the same or not. So I'm just not going to count that as an answer. Okay? So either I'm going to change that on the test, or I'm just going to say don't worry about letter C. All right. Next problem. For which values of x is the following expression undefined? Remember, undefined is when the denominator is 0. I'm pretty much asking about the restrictions. So I'm going to set the denominator equal to 0. So let me highlight that because that reminds me of my VA. And I'm going to take that and set it equal to 0. X minus 9, x plus 1, 9, and negative 1. So the values that make x undefined are x equals 9 and x equals negative 1. I'm not asking to state the restrictions. I'm asking what values make those restrictions, which is why it's x equal. Okay? For which values of x is the following undefined? Set the denominator equal to 0. Well, there is nothing that makes it undefined, so nothing, which means every number in the whole wide world works. So all numbers work. There is nothing that makes that defined, so all numbers work. All right, given the parent functions, describe the graph. So for the 6, now remember, I'm going to write this as an initial, but you have to write it out. So you have to write horizontal, translation, 6 units, right. X isn't a straight shooter. Then the 8, vertical, write it out. Translation, write it out. 8 units, write it out. Up. That's what I want for that one. All right, this next one is way more complex. And I'm telling you right now, this is how you're going to see it on the test. You're going to have a complex problem and you're going to have to find the answer. You might think you have the answer, but if your work does not match your answer, it's not cutting it. So when I look here, this one looks crazier than this one, so I'll just take care of this one first. So this would be x minus 6, x plus 1. And then when I GCF this, I take out a negative because they both have it. 3 goes into both of those, so that would be 5 plus 8x. Okay? So I factor the top and factor the bottom. But I can't factor this because it's subtraction. What I can do is change the signs of everything to the right and put it over 1. I'm going to rewrite it over here. 8 over 1 plus negative 3 over x plus 1. Remember, when we're adding, we're not crossing things off. We're trying to make the bottoms the same. So if this has an x plus 1, I got to give this an x plus 1. And this is just over 1, so I don't have to give anything. Distribute, distribute. 8x plus 8 minus 3 over x plus 1. Simplify that even more. 8x plus 5 over x plus 1. So really, this simplified to this based on all of this work right here. So if this is my left one, let me write this, 8x plus 5 over x plus 1 times, because that's what parentheses means, x minus 1, or 6, x plus 1, over negative 3, 5 minus 8x. Now, this is like the multiplication. Same thing on top, same thing on bottom, by. 8x plus 5 and 5 plus 8x. They're the exact same things because it's adding, by. So then I'm left with x minus 6 over negative 3. I don't see that answer. Why? Because I don't like negatives in the denominator. So I want the bottom to be positive, which means letter B, C is out. And if I'm taking that away, I need to give it to the top and give it to the bottom. So it's really negative x plus 6. And negative x plus 6 is really 6 minus x, where that's positive and that's negative, over 3. There's my answer. That was a workout, probably going to be worth, I feel like 5 points. Feels like it's going to be worth a lot of points. All right. Which of the expressions is defined for all values of x? So this is going to be worth a bit because you're going to have to actually find the restrictions. So if I set this equal to 0, x plus 1, 0, and negative 1. This has restrictions, which means it's not defined for all values of x. So that one's out. Show your work. If you just go because there's an x and it's out, that doesn't make sense because they all have x's. Then this is x minus 4, x plus 4. So I get 4 and negative 4, which means those two are my restrictions, which means it's not true for all values. That one's out. I can't factor this one, but I can do the quadratic formula. Negative 9 plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. Then I end up with negative 9 plus or minus the square root. 4 times 12 is 48. 9 squared is 81. 81 minus 48 is 33 over 2. Since I could literally pick up my calculator, I know this isn't the best one, I could pick up my calculator and find the answer. This has restrictions. Negative 9 plus the square root of 33 over 2 is a restriction. Negative 9 minus the square root of 33 over 2 is a restriction. Since it has restrictions, this one's out. Now, I will tell you, if you would have ended up getting negative 9 minus plus or minus the square root of negative 33 over 2, negative implies imaginary numbers. Imaginary numbers aren't real. So this doesn't count as a restriction, so that means it would have been C if that's negative. Okay, so now let's check the next one. Set it equal to 0, subtract 11, x squared equals negative 11, square root. Ah, there's an imaginary. You can't have imaginary restrictions. If you have an imaginary restriction, it's not actually a restriction. So because of that, D is one of the possibilities. So I want you to know on your test, remember, if this was negative, this one would be true for all values too. You could have one answer, you could have 3 answers, it just depends. This one I want you to solve it in 2 different ways, which means you need to give me the answer 2 different ways. One way is, and let me rewrite this over here so I can show my work for the other way, is when you were little or younger, you did make an x, multiply what touches. So x plus 6, x minus 1 equals negative 6, because 3 times negative 2 is negative 6. That's one way. And then ... But hold on. Another way is, whatever this guy is, give it to this guy. Whatever this guy is, give it to this guy. And then start crossing stuff off. Notice my work. By. Then distribute. X minus 1, x plus 6. Negative 2 times 3 is negative 6. Do you notice how you get the same thing? But it says solve. So you need to pick one of them to solve. I don't care which one you decide to solve. Okay? I'll solve this one because it feels right. X squared plus 5x minus 6 equals negative 6. Add 6 to both sides. I'm just left with x squared plus 5x equals 0. I factor that out. I get x equals 0, x equals -5. Check to see if I plug in 0, we're good, and if I plug in -5, we're good. I don't need you to solve both of them. I need you to show me that there's equality between them depending on which way that you solve, and that you solve one of them.